All right, next up for our last presentation of the conference, we have Dr. Alexandra Holloway of NASA JPL presenting 5 years and 130 tickets, the vast scope of the Mars Science Laboratory's ultimate flight software release. Alexandra, thank you so much for being here again and leading us off in 2021 and finishing us up here this year in 2022.
Thank you. Can you hear me and see me okay?
We sure can.
Awesome. Thanks for having me again. It's been a pleasure to talk last year, and I'm excited to tell you about what we're working on this year. My name is Alexandra Holloway. I'm the flight software lead for the Mars Science Laboratory mission. I'm not the first lead, nor the second, nor the third. I think I'm number 8. It's been a very long mission, which I'll tell you about in just a minute. My background is embedded systems, and then interaction design and user research, human factors, and then back to flight software. So I've kind of been all over the place in terms of hard and soft sciences. My goal eventually is to work in flight software and design flight software for ground operability. Next slide. So MSL, as you know, has been on Mars since 2012. And the software that we have on it does get, old. We need to update some things on it. We've been updating the software with patches. We've had some new releases, and the one we're working on now is called R13. Just a numbering convention, just a monotonically increasing major release number. Today I will tell you why it's our biggest one and how we dealt with all the things inside it. Next slide. Software upgrades add or replace functionality, fix bugs, and prepare for future use cases. That's like the 3 main categories of why do we even fix software. And we can do it very easily with patches, but every time you make a new patch on top of an existing flight software image, you're increasing the complexity of operating the vehicle. You have to remember, okay, this patch and this patch, they work well together, but what happens if you put this 3rd patch on? What happens now if you put this 4th patch on? And that's when you have all of those patches all together, then you start thinking, okay, wait, maybe we should make a new actual image that doesn't have any of that complexity on it. We have 3 major ways of updating the flight software. 3-ish. We've got the hot patch. It's the easiest one to do. You guys heard of the patching talk probably earlier today. It's 1 or more individual memory modifications, sometimes with additional compiled code. So like there's an object file or something, and a script which runs through the modifications in order and then somehow links the new object file to the existing image. It's done in runtime, very easy to do, pretty easy to test on the ground. We've flown, in our count, 13 hot patches. We've installed them 52,000 times. That's pretty much every time we boot, we will install at least 1 patch. Then we've got cold patches. Cold patches are like a hot patch, so it's relatively low cost to make. It's a little bit more complex to validate and test. But what you do with that is you got the hot patch with all of the minor modifications you're making, and then you burn that back to the non-volatile memory where the image lives, and you bring that back up every boot. So once you've burned it, you don't have to do it again. You've applied the patch. Then we have the full update. And that's the new flight software image, which we compile the code, it makes an image, we break it up into little pieces, and then we send it up 1 piece at a time, assemble it on board, make sure it's okay, and then burn it back to non-volatile memory. That one is a big deal. And we've done 6 of them so far in flight. We're working on number 7. Next slide, please. This is a graphic I put together for you guys. It shows MSL's traverse from the beginning, Sol 1, to approximately when I made this slide, which is about a month ago. And I've overlaid the years. So this is on the far left, we've got Sol 1, and that's the red color is 2012, and then 2013 is yellow, 2014 is blue, and so on. So what I'm trying to show here is how far we've gone for each of those years. I paused because I think this is the old slide package. I have a modified slide later, but that's okay. We'll be fine. So what I wanted to show here is basically how far we've gone for each year and where our flight software updates have been. We've got the full flight software updates, which are in orange on Sols 1 and 5 and 264 and so on. And what you see here in the middle is a whole bunch of space where we've been doing all of this driving and then all of this climbing up onto the mountain that we're driving up to. And not any cold patches or hot patches until you see a couple there on 2808, the cold patch, and 2960, the hot patch. 2960 does not count. We have 2 computers on board. 2960 addressed a vulnerability on the one we're not using. So I'm going to kind of discount that one. We talked about that last year with our talk on our hope. So 2808, though, was our last cold patch that addressed a different vulnerability. And that was the last time we really burned something to NOR. So in all of that time of traversing and climbing, we've been collecting bug reports from the rest of the team. Next slide, please. So we've got, as a result of all of this driving and climbing, we left that with 130 proposals for a new era in flight software on Mars. Just to kind of compare, the previous major release, R12, had on the order of dozens. The new one has on the order of, 100. So we had to figure out what to do with all of these proposals and how to describe these things to management so that we can prioritize and figure out how to work on this stuff and what we should work on. So we divided them up into 4 categories. We've got category A, does it enable streamlined patching in the future? That's really important to us because you know what? This is our last flight software release. We're not going to do another major release. Everything's going to be patched from now on. Is that true? I don't know, probably. But R12 was told that they were the last release, so we'll see. But that's one of our main criteria, is we need to be able to patch easily and safely. Then we've got category B. Is it an existing or necessary patch to address a mission or vehicle vulnerability, which just means, is it a patch we can roll in? Then we've got category C. Is it something that we're reasonably confident will be very low effort and small delta risk? And finally, category D. So category C is like one-line changes. We're opening up this module. Oh, look, there's a typo. Let's fix it. And then category D is their high return on investment that would justify the added effort or risk. So these are the big ticket items that are going to take a lot of people to work on, and it's going to be a big deal. Next slide. And then this is just like you can see what was the distribution of those? Oh, well, most of it is hard stuff. About a third of it is patching and rolling in patches. And then about a third is low effort, small risk, those one-line changes, but mostly we're going to be focused on the hard stuff. Next slide. All right, so we then took these 130 proposals and divided them up into 9 kind of topic areas. We grouped them by, I don't know, it was a logical grouping. It seemed to make sense at the time. And the reason we did that is because we wanted to coordinate the borrowed developers. So Mars Science Laboratory, Curiosity, does not have a flight software team anymore. Most of the developers have rolled off onto other missions, and we had to borrow those developers. We had 31 of those that we had to borrow. I usually offer to bake brownies or cookies, but the joke is I can't bake, so I will boil some cookies for you if you promise to work on this flight software. Strangely, nobody agreed to that, but they still wrote this software, so that's great. So coordinate those developers. We wanted to say that these developers are working on this package. We wanted to discuss inclusions at a higher level of abstraction. So it's we have 130 JIRA tickets. It's one thing to say, are you working on JIRA ticket number, whatever, but if you're talking about a broader picture, you can say, well, the ARM package is almost done, or the instrument package is nearing completion. We can keep track of asynchronous development and testing with this method. And then we can identify a single point of contact for each package. And this turned out to be crucial, because if we're coordinating 31 borrowed developers, and we don't have a testing team either. So a lot of our testers were either some of those borrowed developers, or they were people from our own systems team. So there's a lot of coordination that needs to happen. And it was really helpful to say, okay, you are in charge of the instrument package. Go make sure that everything is being done. And here's exactly what should be being done. Well, close to that. And it helped us communicate efficiently. Like we could go to a big meeting with all the bigwigs and say, oh yes, we have 9 major packages, and here's what you'll get when you approve these 9 packages. So I've got them here. I'm going to walk through them real quick. VO thinking while driving is the first one. It's integration of the new visual odometry thinking while driving feature, which allows for more efficient science. We predict that we're going to be able to drive 50% farther. And we're going to, as a result, also save power. We're projecting about 30%. And this was being developed as a hot patch previously. So it's, and we can't both develop a hot patch and develop R13. So it's really exciting that it's getting some traction getting pulled into R13. And I have a little footnote there. You can see more about it at the Aerospace conference, where Mark Mamone and others will be presenting on VO thinking while driving. The second is Aegis improvements and integration. Aegis is the automatic autonomous targeting tool. It helps scientists pick out the targets that they should be looking at when otherwise nothing would be getting done. Previously, Aegis, so we're already flying Aegis, but it's being loaded at runtime as a component, and now it's getting integrated into R13. The benefit there is if something were to happen to cause us to go into safe mode, we would still have that capability. Number 3, ARM and sample processing operation improvements. And I've got a footnote here. You can see Art Rankin's paper in last year's Aerospace conference, integration of an ARM kinematics hot patch, which is we had an error in our ARM inverse kinematics algorithm, which we patched as a hot patch. So it's a couple of instructions that were overwritten, that are overwritten every time we boot. We do it at boot time, and also a loadable object that we can then call as well. So that's getting integrated into R13. And we have a couple other improvements, such as new commands to increase operations efficiency. We've got instrument operations. There's 2 hot patches that we've been in use for years, which we're now going to roll into R13. And we've got improvements to instrument handling and operations, specifically the way that the cameras work, the way that stereo works, and some bug fixes related to how some of the mechanisms open and close. The 5th package is data management, sequencing, and patching improvements. And this is a plug, number 3 there. The footnote is a plug for Mark and my presentation in this workshop. which you can see as a pre-recorded presentation. So please see load and patch, improving hot patch capabilities. So which basically is we created a new infrastructure that will help people write code that will patch the software. Right now it's super cumbersome. It takes a lot of instructions, and a lot of places where we can make mistakes. In fact, one of the patch implementation checklist items is to pause and meditate on the losses of some of our spacecraft due to patching. We've also got some improvements to the creation and downlink of data so that we can increase, so we can reduce how much data we're sending, save bandwidth that way. And the way ground processes those data products as well. Mobility improvements. We have 2 new commands that improve the way we drive, and maybe you came to our presentation yesterday. Got a footnote there. I'm sure it'll be on YouTube in a bit. These wheels are made for arcing, was our presentation yesterday about that. And then we've got power and thermal improvements, which are minor improvements to the way preheat works, and then how data products are generated. So that's going to result in, again, more time being awake, less. So the preheat part is interesting because every once in a while you can get into this state where you're heating, and then you're heating up to a specific target, and if you miss that target by a little bit, it'll say you failed the preheat. So we're making it a little more flexible so that you can still get to that target and then not fail, and then continue to do what you were supposed to do, rather than, panic and shut down, which is not what happens, but that's catastrophizing. Number 8, fault protection improvements. We have some updates to default spacecraft parameters and other outstanding corrections, and rover planner improvements, which are expanded capabilities for arm targeting and arm placement. This was the biggest slide, so that's why we're almost done. I have 1 slide left. Next slide. There we are. Okay, so where are we and what happens next? Well, we're going to wrap up VNV. We've been wrapping up VNV. So it's been 5 years to get where we are, right? From the moment that the R13 flight software update was proposed to right around now, it's been about 5 years. We are done with development. We're done with most of our post-development stuff. We're wrapping up VNV testing on the hardware, verification and validation. Then we're going to deliver the software. Who do we deliver it to? To the regression team. The regression team is then going to conduct 41 regression tests across 15 subsystems. That's going to take a while. That's a lot of regression tests. We only have 1 test bed. That we don't have a ton of people because they're all rolling off to other projects. So it's going to be quite the undertaking to conduct those regression tests. Then we're going to complete software release certification review, which is going to certify the software for flight. After that, we uplink however many flight software fragments we end up with to the rover. The rover will install on non-volatile media, and then we'll perform the transition to new software on this computer. So we're ballparking that to take about 1 more year. So maybe this time next year, we'll be talking about how our 13 installation went. And that's all I had.
All right, Alexandra, thank you so much. We do have some time for a few questions here. First question from one of your colleagues at JPL, Tim Canham. Can you give us an idea of the BDR, Brownie defect rate, is his question.
I think that's a reference to my brownies, or is that a reference to, is that code for code? My personal brownie defect rate is 100%. I'm terrible at baking.
All right, next question. What sort of testing and verification do you typically do for patches versus full updates?
Yeah, so it's okay. So our development cycle is pretty typical. We've got, development and unit testing. We have peer review, and then we have testing in a software test bed, and then we have testing in a hardware test bed, and then we have regression, where we regress the modules that we think might be affected. And then we have sol in the life testing, which is where we pretend we're doing whatever it is the rover does on Mars for a sol, for a day on Mars. For a full flight software release, that's what's going to happen, every single one of those. For a patch, some of that is not valid. There's going to be a lot more hardware testing. We can't do software testing of our hot patches because our software simulation environment is not VxWorks, Rad. I mean, it's not the same chip, right? We're doing it on a much different processor. So we can't poke into memory addresses and expect the same result that we would have on hardware. So we spend more time in the test bed when we're doing that. And then we also call in folks like Tim Canham, Mark Mamone, to be our peer reviewers, somebody who's gone through this before, just to make sure that we're not really messing something up, because the stakes are very high in a patch. It might seem like a no big deal thing. Yeah, we'll just poke that into memory. But we've lost spacecraft that way, and that's very dangerous.
Yep. And that leads into the next question from Peter. Applying patches seems to be a more complex and unsafe operation. Why not apply the full update instead?
This full update is taking us 5 years plus, right? It's going to be about 5 or 6, maybe 7 years until it's done. Our fastest flight software release, at least that I've seen, full image, and maybe that's not the case because I haven't been on the project very long, right? Because there's the turnaround, I'm number 8 or 9 in the queue. But last year we installed our Hope. Our Hope was an emergency full software update for our crippled computer to be a lifeboat for our good computer, right? Because the crippled computer's non-volatile memory went away. We had no file system. We have to put something on there. So if we swap over, we can still do things like communicate. So this was like top priority. We had to get it done really fast, as fast as possible. And how long do you think that took? As fast as possible. Development, peer review, testing, regression, sol in the life, send it, ship it, fly it, install it. 18 months. A patch, you can do it in a month. You can do it in, if you've got a team of Tim Canhams, you can do it in 3 days. It's not that big a deal to send a patch.
Okay. Next question from Leonidas. Were any of the 130 patching proposals identified by Cobra? If yes, in which of the 4 categories did they belong?
No, we didn't know about Cobra, and by we I mean me personally. We used Holtzman's other tools that were around at the time. We ran Scrub when we were doing our Hope, and it came up with a lot of violations, and it was actually really hard to figure out which of those violations to address, because we had to write a script that basically constrained the violation list to only the lines of code we touched to make sure that we're looking at our stuff, or the files we touched, or the modules we touched. Because there were, maybe standards have changed since the code was written, but it hasn't been touched since 2012, right? So or 2012 is when we landed. Yeah, so I guess it's been touched since then, but it hasn't been touched in quite some time. But that's a great question. I'm excited to find out.
Okay. Well, unfortunately, that's all the time we have. We do have a couple of other questions that we're going to move over to the Slack for some continued discussion. Thank you again so much, Alexandra.
Thank you.